This shows 12 hours at the famous Bay of Fundy in Nova Scotia, Canada. It's the biggest tide change in the world. But what force could move such a massive body of water? Gravity. Here's the Earth rotating on its axis every 24 hours. We'll now draw the Earth as a diagram with its surrounding layer of ocean. And to the right is the silvery moon. Everything is attracted to everything else in the universe with the force of gravity. So the moon is attracted to the Earth, and the Earth is equally attracted to the moon. Notice that the two force arrows are the same length, showing the gravitational attractions are of equal strength. But we're only interested in the force on the Earth here. The moon pulls on the ocean closest to it and makes it bulge outwards. When the Earth rotates, the sea level is higher at this point in its rotation, causing a high tide. And a low tide where the oceans don't bulge. So you'd expect one high tide each day. But here it gets interesting because there are two high tides a day. How come? This is because the strength of gravity is greater when objects are closer. We'll call the location of the ocean on the near side of the moon, point A, at the centre of the Earth, point B, and at the far side ocean, point C. The strength of the moon's gravity is strongest at A because it's closest to the moon. So the part of the ocean that bulges towards the moon most is at A. But the moon's gravity also pulls on the Earth, moving it towards the moon as well. This has two effects. First, it makes another bulge at C. Second, it fills in the bulge at A, but not completely, because A has moved further towards the moon than B. Lastly, the far side ocean at C is also attracted to the moon, but it moves least because the moon's gravitational pull here is at its weakest, being farthest from the moon. This leaves a partial bulge at C, though not as big as the one at A. Now we can see why, when the Earth rotates through 24 hours, it goes through two high tides and two low tides. But there's another surprise. By the time the Earth has rotated once and arrived back at its original position, the moon has moved on a bit because it's orbiting the Earth at the same time. That means that the Earth has to catch up with the moon, so the next day's high tide is about 50 minutes later. The moon rises and sets about 50 minutes later too, because the Earth has to catch up with its orbiting moon. You can even test this by timing the moonrise or moonset from one day to the next. Or check out some tide charts to see if the